Hello, in this video I'm going to solve the following problem for you. Determine a third-degree polynomial p of x such that for all real numbers x, p of x minus p of x minus 1 equals to x squared. Using this polynomial, show that 1 squared plus 2 squared plus 3 squared up to n squared equals to n times n plus 1 times 2n plus 1 over 6 for all natural numbers n. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, the polynomial p of x will be p of x equals to 1/3 x cubed plus 1/2 x squared plus 1 over 6x plus d, where d is an arbitrary real number. The interested reader for the same type of problems can refer to the following playlist. To reach to this playlist, you can download this PDF file. The link to this is in the description below this video. Okay, so now I want to find a third-degree polynomial p of x satisfying this condition for all choices of x. So we know that in general p of x, a third-degree polynomial, can be written in this form. Yes? Knowing that this relation should hold for all possible values of x will allow me, as you will see, to fine-tune these three parameters, but not d. Okay, so what I will do, I will go here, instead of p of x, I put this. Instead of p of x minus 1, I put this, in which every x is now replaced by x minus 1, and do the algebraic calculation. So ax cubed plus bx squared plus cx plus d, and then minus p of x minus 1, which becomes ax minus 1 cubed minus bx minus 1 squared minus cx minus 1, and then minus d. Okay, it's clear that this minus d and that d are gone immediately. So the next row will be ax cubed plus bx squared plus cx minus, I raise it to power 3 and multiply it by minus a. So let us do it in one go. The calculations are simple. So ax cubed, then the next one becomes positive 3ax squared, negative 3ax, and then positive a. The next one I will do the same thing. I square it and multiply it by minus b. So it becomes minus bx squared plus 2bx, and then minus b. And the other one is simply minus cx plus c. And now what happens? This ax cubed and these are gone. This positive cx and that cx are also gone, and this minus bx squared and that one are also gone. So what more? So you see what is left for me. Of course, on the right hand side I will have x squared, so I have to write this is supposed to be equal to x squared for all choices of x. But if I want to organize it, so I have only 3ax squared on the left, and then here I have minus 3ax and 2bx. So I factor an x out. So from 2bx, 2b is left. From the other one, minus 3a is left times x. So what I did, I considered these two so far. I also considered this term. So what is left for me is positive a minus b positive c. So it becomes positive a. So let me change my color. Positive a negative b plus c. This is supposed to be equal to x squared for all choices. So this gives me a system. The x squared coefficient is 3a. The x squared coefficient is 1. So 3a should be 1. And then the x coefficient is 2b minus 3a, but there is no x here. So this means 2b minus 3a should be 0, and the same true is for a minus b plus c. That should be also 0. So you see that there is no condition imposed on d, so d can be any arbitrary real number. Okay, so from here a becomes a third, and then using this equation 2b is equal to 3a, but 3a is 1, so b becomes 1/2. And now in this equation a is 1/3, b is 1/2, but c is unknown, so I have to calculate this and find c. So 1/6 is the value for c. Yes, let me double check. Yes, so c is also this one. So what is my p of x? Let me change my color. So the p of x that I was looking for is a polynomial in which a is a third, so it becomes 1/3 x cubed, and then b is 1/2 x squared, c is 1/6x, and then you see that d is an arbitrary real constant, and that is exactly the first part of the problem. But how can I use this fact to find the formula for the sum of the squares from 1 up to n? That is also very easy, because if this is valid for all choices of x, this equality is valid for 1, 2, 3 up to any natural number n. Okay, and because d is an arbitrary value, I can choose whatever I like, it doesn't matter. So the simplest possible choice is d equals to 0. You don't have to choose d equal to 0, but the simplest choice is d equal to 0. If you don't like it, choose any d, but then you will see that it will not play any role in your calculations. So what I will do, I will choose x to be 1. So then it means p of 1 minus p of 0 is 1 to the power of 2. Intentionally I write 1 to the power of 2. So if I choose x to be 2, it becomes p of 2 minus p of 1 equals to 2 to the power of 2. Understandable? Because this is valid for all choices of x, including these natural numbers I am plugging in, and I am intentionally not expanding them, not calculating them. I want to keep them as 1 to the power of 2, 2 to the power 2. The reason becomes clear shortly. So if I choose 3, then I will have p of 3 minus p of 2 is equal to 3 to the power of 2. And if I continue this list until I hit x equals to n, then it becomes pn minus 1 is equal to n squared. And now what I will do, I will add them side by side. So I will add all of them. So now the interesting thing happens is that the left hand side is a telescopic sum. What does it mean? It means that this term is cancelled by the next one. This term is cancelled by the next one, because the difference between x and x minus 1 is always 1 unit. So the next term coming from the next row will cancel the previous term. Yes, so this will continue. So this one will be cancelled by the next one, and if you continue this list, what will happen? This one is also cancelled with the previous one. Two things are left. One of them is p of 0, and the other one is p of n. And the right hand side, what happens is the sum of these terms that you see. And that is exactly the sum that I want to calculate. So when I add them up side by side, the left side becomes p of n minus p of 0, and the right hand side becomes 1 squared plus 2 squared plus 3 squared plus up to n squared. Okay, but look, what is p of 0? P of 0 is this expression if I replace x with 0. So if you don't mind, let us just work with d. So this is nothing except d. But what is p of n? P of n is this expression in which x is replaced by n. So let us do that. P of n becomes a third n cubed plus 1 over 2n squared plus 1 over 6n plus d. But what is p of 0? Again d. What is on the right hand side? Exactly the sum I am interested to calculate. Yes? So then what happens? This d and that d are gone. I am done. So this one is equal to this sum. but that is not exactly what you see in the problem. So the only thing that we have to do, so let me first of all cancel these two, and the only thing that I want to do is to calculate this. And to do this, I factor n over 6 out. So from here, 2n squared is left. Why is that? Because if you multiply this back, n squared n becomes n cubed, 2 over 6 becomes 1/3. So that's correct. The next term will be what? It will be 3n, and the final term will be 1. But this is extremely easy to see that this expression can be factorized to n plus 1 times 2n plus 1 divided by 6. Yes, you can check it out. N times 2n is 2n squared. N times 1, 1 times 2n. N plus 2n is 3n. And 1 times 1 is also 1. What is the left side? The left side is this. What is the right side? Is exactly the sum that I want to calculate. So using this nice idea, I was able to find the sum of the squares from number 1 up to any natural number n. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.